The Spalding Plots, mapping 100 years of vegetation change. In the early years of the 20th century, the scientific discovery of deserts began in earnest. Until then, deserts were about as unknown and enticing as the surface of other planets are to us today. In 1903, the new Carnegie Desert Botanical Laboratory on Tumamoc Hill became the world's focal point for desert studies. Along with the new interest in desert environments came a new way of thinking, observing plants in their natural environments rather than in museums or in a greenhouse. The men and women that came to work on Tumamoc in 1903 were pioneering ecologists. They considered the whole 860-acre property their laboratory. One of the first scientists to come to the Carnegie Desert Laboratory was Volney Spalding, a forestry professor from Michigan. In 1906, Spalding carried out a simple idea that is still considered a stroke of genius today. Driven by curiosity to know how long it takes deserts to recover after human disturbance, and to test theories of how plants organize themselves over time, he knew he needed a long-term perspective. First, he set up 19 small, that is, 10 by 10 meter plots of random desert, scattered around the hill in different settings, permanently marking the corners with stakes. He identified and mapped each plant within that square boundary on grid paper of his notebook. He intended to track changes over time. How long? He didn't know. This required a lot of trust in the future. As it turned out, Spalding's faith was rewarded. Most of his plots are still being monitored today, over 110 years later. Spalding's plots are now the longest continuously studied vegetation plots in the world. The following animation shows Spalding's plot number 16. There are 10 maps, each made about a decade apart, between 1928 and 2010. Put together, they give a picture of changes over 100 years. Each color represents a different species, and each shape is the area it occupies as seen from above. 3 of the most common plants are labeled here, so you can follow them over time. Okay, now let's look at that sequence again and focus in on 2 of those species, creosote bush in green and Crumeria or range rhatany in pink. In 1928, creosote bush dominated the plot. When browsing animals were excluded by fence, the better-tasting Crumeria grew back. After a dry period in the 1950s and 1960s, an association became clear between the 2 plants as Crumeria began to cluster around the creosote bushes, plants whose roots the Crumeria plant parasitizes for additional nutrients. Both species then died back during the current dry period. Scientists here at the Desert Lab are still collecting and analyzing the volumes of data coming from the Spalding plots. Perhaps most important, long-term data provides a lens unlike any other. For example, if you were to look only at the early 1920s, one would draw a conclusion very different from the story told from the 1990s alone. The desert is dynamic, constantly changing. We will keep watching.